Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in.
Hello, I'm Nick.
Hello, I'm Ed.
And this week you don't hear us with John this week. We had some inclement weather here in town the last 24 hours. And, he kind of was impacted by that. So, he's doing that and also spending time with family for some birthday events. So, last week we kind of talked about, robot safety and stuff like that, and kind of got into, that side of the house. This week, like we told you we would, we want to talk about kind of robot planning. And we want to go through what is the robot implementation checklist and kind of break that down. What is kind of required and what we think is kind of required to go through that process and, onboard a new robot and also, beef up the system. So, when we're talking about, robot, new robot purchases, integrations, checklists and stuff like that, what are you thinking?
So the first thing would be application. So what is the application? So you determine what the application is and why you desire a robot for that particular application. So here's an example. I want to build wheelbarrows. If I would like to build wheelbarrows, how much of the process is prefab and how much of the process has to go through a process? Mm-hmm. Or excuse me, not a process, but how much manufacturing am I doing in-house?
Right.
So if I already have the components and I just have to join the components, then that tells me what the application is.
Yeah.
So I'm doing some handling, maybe I'm doing some welding. All right, with the handling and the welding, after that you have to look at what is the capacity of the robot. I mean, what's the motion? Mm-hmm. So motion meaning how far can it reach?
Yeah.
What's the work envelope is the technical term.
Yeah.
The other thing you want to look at is what's the payload? How much weight can the wrist lift? So center of gravity comes into play. The next thing you want to look at is if you're welding, what type of welding are you doing? Are you doing MIG? Are you doing MAG? Are you doing stick? What are you doing? Mm-hmm. Are you doing a wire application? So then you have to look at feed rate, and that means how fast the robot is moving, mm-hmm. and the speed of the wire as it goes through the head as it begins to weld. The next thing you have to look at is guarding. What type of safety factors would I have to look at? Is the robot only doing the joining part? Or is it doing handling and joining?
Yeah, that's also where space would come into play too.
But you would have to have am I going to have a magazine? Mm-hmm. Am I going to bring a pallet of parts to the line? So how does the robot, what are the safe zones for the robot and the human interaction?
Where's the feed points?
Yeah, so it'll be at a home position. When it's at a home position, you let the robot signal to the robot that, hey, I'm in the area, and it stays there until you leave the area. Mm-hmm. So maybe you have to have some type of laser scanners, light curtains, something, so that it knows that you're in that area. And then the last thing you have to look at, what's the cost? Is it cost effective? What is your ROI by incorporating that robot? And we're talking about a small application. We're not talking about like running, sales with a whole plant. We're talking about you have a single product that you're producing,
like a support robot,
like I said, building wheelbarrows, go-karts, whatever it is,
small things.
Yeah.
And the thing is that's kind of where you get into, for example, if you really thought about using robots for machine tending, pulling things out of CNC machines and loading things into CNC machines. I know Fanuc has an entire setup just for, CNC machine tending and stuff like that. And I think so does ABB, if I'm not mistaken. But, the thing is, if you start talking about like that type of robot, you start getting into a really interesting envelope, because now, you have your human-machine interaction being extremely close. You're dealing with Cobot type sensors, if needed, to full robot cell implementation. So the like you said, doing small part manufacturing, either that or one day I saw something online. It was a KUKA arm, or it could have been another type of Cobot that was on a AGV, and that AGV was tending to 3D printers. They would do lights out manufacturing with machine tending, and stuff like that. So you do have that, mobility parts, but we're not talking about an entire cell build. If we're talking about an entire cell build, you're talking millions, of dollars worth of robots, safety equipment, transfer stations, and stuff like that. If you think about it, if you're choosing to do a Cobot versus a industrial robot, the picking process for the type of the robot itself is pretty much the same. It's just like you said, the application. Application is going to dictate what side of that coin you go to. So do you go to a Cobot because you're going to have somebody in the station doing the welding for you because you don't have the technology to do onboard welding? Or do you need somebody to set the parts and set the geometry for that robot because you don't have hold downs? That's when you start dealing with either a very highly complicated robot human interaction standpoint of a loading cell and rotary tables and all the other stuff, or do you go to a Cobot based system of where everything is a lockjaw type of system? You load everything into it, tell the little robot to go, hey, go ahead and weld this for me, and it continues the process.
So I'll give you another example. So say that I was building a trailer, and part of the trailer is, hey, I have cross members that have to be welded, or maybe I'm doing the hitch part, or maybe I'm doing the part that's involved with the axle. So maybe it's three processes: axle, the framing, and the hitch. So the attachment.
Right.
So maybe the first part is the cross members have to be laid into some tooling,
like a jig
tooling, and then that is basically your setup. So the robot doesn't do any of the setup. The human lays the parts in and say, hey, it's in the jig. The robot goes and weld. All right, then the human works on the next part. So the next part would be, hey, we need to make the portion that's the hitch. So okay. The human, once again, brings it over to a fixture, put it in a fixture, and it does that. Okay, the axle's a little bit more complicated because you may have bearings and things like that. So not only does the robot weld, but after they finish welding, maybe it has to put bearings in to have bearings in place. And then the last portion, of course, is assembly. The human will probably do the assembly because of the mobility of a human as opposed to what a robot. Doesn't make sense.
Which would make sense, yeah.
For that type of motion. You can, but it's not, the ROI is not there. So if we're looking at it, we got three processes.
Right.
We build the frame, we build the hinge or the hitch. I'm sorry, the hitch. And then the last part is we build the part to connect
like the axle tubes and stuff like that.
The axles and the everything we need to. So everything would probably have to be turned over. So the robot would probably
like a rotary table,
or the robot would just flip it.
Oh, okay.
If the robot has enough capacity, you can flip it. Or if not, you can just have something that just flips it over.
Makes sense.
Or, in my opinion, it's not necessary to flip something already all the way over. Maybe you just flip something up. Then
like
you bring it apart. Yeah, just 90 degrees. Robot welds what it needs to weld. Robot moves out of position, flips back down. The hitch goes on. Robot finishes the hitch. Or maybe the hitch is even built into the frame. So we take the hitch and the frame in one process, but the axles are done last. But however that is, the human is loading the parts. That's one application. Another application would be the human loads the parts in a magazine. Mm-hmm. The robot picks the parts. The robot places the parts where they need to go. Another robot does the welding. Mm-hmm. So it's different ways to do it. You can have, a person load magazines, or you can have a person load, like you said, a jig.
Like a fully automatic station versus semi-automatic station.
Yeah, and they both kind of almost automatic because someone still has to load the magazine.
And if you think about it, if you really start getting into, and this is why I kept bringing up rotary tables and stuff like that. You start really getting into, ergonomics and stuff like that, because people don't think about it, but ergonomics of a robot. You're not really too worried about a robot getting an on-the-job injury. The human loading the jigs and loading the tables and stuff like that, the clamps. Yeah, that's where you might get a little bit of bumps and bruises, especially if it's not built to the best of capacities. Mm-hmm. But when I start thinking about like robot ergonomics, it's what type of head do I have on this robot?
So another way to say that is your work envelope.
The envelope, yeah.
So like, you don't want a robot doing unnecessary motion.
Right.
I mean that's what I mean. You don't want a robot to go way over here, because you can have a program path that makes it more efficient to do what you want to do. So the ergonomics you're talking about is just the work envelope for that robot and the program path.
And the thing is with that, you're doing also collision avoidance.
Yep.
And you're trying to make sure you don't have multiple robots, inadvertently clapping. Which if you have a robot that claps, then you have some other problems to deal with. They're not supposed to be high-fiving each other, so please don't do that. But the thing is as you think through the subset, is how many robots do I need? And that goes back into our space. It's we go from space to robot choice to robot amount at that point, because of the fact that do I need one robot to do this process? Do I need two robots to do this process? Like you said, am I going to have a robot load from a magazine and then another robot complete the process, or do I let a human do it? And that's when it gets kind of interesting. We start talking about like machine tending robots, for example. You start looking at CNC machines. You can have multiple robots working in the same envelope, because you have one loading and one unloading, depending on the speed, I guess, of the work process, which is another topic of how fast do we want this process to go. But are multiple robots necessary for that application to take effect? Because dual robot machine tending, I saw a little bit of it at Automate, and they had one that would load and one that would unload. And it was kind of funny to watch because of the timing. The timing of these things had to be precise. One couldn't start moving until the other one was clear of the process, which, if you think about it, with that actually slows down your process. So multiple robots inside one process is not always the fastest option.
Well, it depends. So I'll give you an example. So it depends. Multiple robots are used because of utilization.
Right. Makes sense.
You typically want to have a certain amount of utilization out of each robot. That's where you get into, hey, I can have one robot do two jobs, which is okay. But you have to account to, if I want a dozen eggs, I can do it I can take the egg from the basket and put the egg over here in another basket. So I had 3 eggs in this hutch. I took these 3 eggs, put them in the basket. So I took them out of the nest, put them in the basket. So two operations.
Right.
However, I try to do that in one operation. Hey, I'm just going to chunk the eggs. So now I got to worry about cracked eggs. So it depends on what you want to do in that aspect.
Right.
But generally, you're right. One robot can do 2 operations.
What would be the optimal amount? 80%, 70%?
Most people want 100%, but I would say 85 to 95% is what you're going to get.
Okay. So if you have two robots, you want to run both of them at 95%, or do you want to run the cell at 95%?
You want it balanced over the two robots.
Okay.
You don't want one robot to work more than the other robot.
Okay.
One is muta, so you're losing. It's wasted movement. So you don't want any wasted movement in a robot. If one robot can do two of the jobs and you only need a certain amount of widgets, then it makes sense to have one. But if one robot cannot do that, and I'm running it at 100%, then also there's wear to consider. Now, if I can run it at less, then I extend the life of that robot, as far as the mechanical wear that you're causing on the robot. Because if I'm accelerating at so many millimeters per second, you know, it has to stop. You have to cut on brakes. Brakes are normally friction based. Those wear after time. Eventually, you'll start to, you know, go further than you were supposed to go. You'll be out of position and so forth. But if I was to take and extend it over the life of the robot and say, over the life of the robot, I get 25 million cycles. If I take two robots and split those cycles between two robots, then I extend the cycles. I could possibly get 50 million cycles.
Makes sense.
You know, so you can look at it that way. If it's a small company, it's not. That's probably not their number one consideration. Their number one consideration is that I don't have to have a person doing this particular task. I can put that person on something else. I can use that person's knowledge, those person's skills somewhere else, and all of the stuff that's just it's rote memory. I let the robot do it. If you've welded something before, you build up muscle memory. I can program that into a robot, and that guy can do more of design, or that person can do more design. Hey, let's make this trailer better. You know, instead of us having to waste this amount of wire welding the robot, if we construct the framing in such a way, we can reduce the cost of the material. We can reduce the cost of the wire. We can reduce the cost of the energy, and so forth and so forth.
And this goes to another point that I've kind of made, you know, over the while, is that, you know, the implementation of robots is not there to take somebody's job. You know, I see it a lot, especially in, you know, blue collar jobs and stuff like that. Oh, they're here to take our jobs. You know, they're going to take all of this from us. And then they blame the companies who want to implement robots for the removal of American jobs. It's not there to take a job from somebody. If anything, it is there to promote the well-deserving people to another position. If I have a weld robot, like you said, and I bring a weld Cobot in, or a main weld robot, and I say, hey, guess what? This robot is going to build brackets, multiple bracket sets for all eternity, right? Cobots you're going to get a little bit higher life cycle out of, because they do one thing and one thing over and over again to a point.
And repeatability.
And repeatability, yes. And safety. You're not going to have a robot that if it decides to clap a human, then, well, guess what? He just went on the really big Ginny Craig diet. But the thing is, you can laugh, it's okay. But the thing is, you know, I've taken that weld guy, that welder, and said, hey, guess what? You're now a weld engineer. You're now going to be responsible for this robot. You're now responsible for its operation, to design its weld paths, to set its weld paths up, to make sure that it has material, and make sure it runs. I'm going to give you an operator to load it, so you don't have to load it anymore. Now you're responsible for a cell of robots.
Yeah,
or of cobots.
Or the operator loads a magazine. I am a proponent of loading a magazine.
Right.
You load 50 parts in the magazine. Then the guy can go gather the next set of parts that's got to be placed and place them. But the thing you said is here's the key to what you said. By allowing the guy that is the expert. The expert in most plants is not the maintenance tech.
Nope.
It's not the engineer.
Nope.
It's
Far from it,
most of the time the person that's at the line every day.
Exactly. It's the operator.
It's the operator.
And those are the people that we want to make sure are recognized. And we want to make sure that those operators who know that job, like you said, better than everybody, they're the ones who get the promotion to take care of these robots, who are the ones that are going to be able to see their career strive and go forward. Not Joe Schmuckatelli, who's an engineer who doesn't even know how to use a protractor. You know, the problem is an issue that we have these days with engineers is the fact, and I know we do have people who are engineers who listen to this. However, you might be one of the few or maybe none of the all, is the fact that we have engineers who can't figure out how to engineer. They forget what the process and the reason behind why they are an engineer.
Or we have library engineers.
Right, exactly.
So this guy takes what somebody else did. I look at the process of incorporating robots as a bootstrap process.
Right, and it should be.
So if it's a bootstrap process, the operator becomes the specialist.
Exactly. Everybody needs to move up.
The technician becomes the engineer that's over the process, and then the engineer becomes the architect. So each of those have worked in that space, and when they move up, they have a unique understanding of what the other person's job is. And eventually, the person that became the specialist will move into the maintenance engineering role. And then so forth, and that guy will become the engineering manager. And that's what you want. It is a huge mistake, and the biggest mistake that we have made in manufacturing in the world.
Yep.
Is somebody saying, I want a bachelor's degree.
Yeah.
No one can translate to me. You can't prove to me that a guy with a bachelor's degree is any different than a guy that's got 10 years of experience working on equipment in the line.
I 100% agree with that. And, you know, for me, you've heard me say this, and I've actually got a YouTube video I have to publish one of these days. I recorded it when we were at Automate. Is, you know, I have my bachelor's, I have my master's, I'm working on my doctorate, you know, but the thing is, I'll tell you this, is it worth it? For me, it was, because, you know, I find fun in it. However, the thing is I want to see more people go through community college, go through technical universities, be experts in their field. And for me, as I get my own company off the ground, those are the type of people I want. I want the people who are not afraid to say, hey, guess what, that's wrong, and here's why. Here's my common knowledge and my experience who tells me that's wrong. I don't want somebody to tell me, hey, the book told me it was wrong. I don't give a shit about the book.
So don't get me wrong. I'm not saying that we don't need engineers. Engineers are architects.
Right.
Architects understand what you have to have. They understand, hey, you said I need this capacity. That guy can figure out what you got to have.
Right.
The issue is, okay, now I'm asking the architect to build a house. That's not what the architect does. The person with the skilled labor builds the house based on the specs that are given from the architect. That's the issue. You have people that are coming straight out of school that have no idea how to assemble what they're asked to assemble.
Right.
So architects design, skilled labor implement the plan. They bring it to life.
And, you know, I really think that as people, you know, come to these companies and stuff like that, and, you know, as we keep going down our path of robot implementation, is they need to be trained on that. They need to be trained on, how do I implement a robot? How does this impact my job? How do I move up by doing this? You have to make that very crystal freaking clear. If you're going to implement robots, you know, even following anybody's steps, it doesn't have to be what we do, because, you know, who are we? But the thing is, make it crystal damn clear that, hey, guess what? I'm not taking your job. I'm going to promote you. I'm going to make you better in the workforce.
It's called investment.
Right. And the thing is you don't, and, you know, I know how you like using, you know, magazine sets and stuff like that for robots to pick their own parts. However, to get started and get somebody comfortable with being around robots, you don't have to go to that extent. You can start with a Cobot that has its own little thing, and you clamp everything together and off you go. You know, ABB's got those. We saw those at, you know, a lot of other places have them. But the thing is to get people interested. And have one, you know, if you don't even use the robot for manufacturing and you have it on the side doing something where people can play with it and kind of get familiar with it, they're going to want it more. They're going to want something that they can touch, feel, build with, and interact with, and learn. Because the human psyche is going to tell you, I want to learn more and more and more. So they're going to want to learn more about these robots day in, day out, until it becomes second nature.
Well, I'll give you an example. I'm going to give an example. But before I give an example, I'm going to explain what I mean by magazines.
Oh, I get it what you mean, but they may not. But I know what you know. I think I know what you're
If you're using racks, that's a form of a magazine.
Okay, well, that makes sense.
If you have a pallet that has parts on it, that's a form of a magazine.
Yeah.
You can have a flat magazine or you can have a vertical magazine. It depends on what you want.
Right.
But if you're putting something, if you're taking parts or pieces and putting them on something and stacking them, that's a magazine. However you want to use it. Now, you can just have a pallet. That's one way of doing it. But if it's a gravity-fed magazine, I can have the person that's putting the parts in the machine go do other things.
Yeah, which makes sense.
Which, for a small business to be competitive,
oh, I agree with you.
You have to figure out how to make yourself more efficient. But it's up to the company. Now,
right.
And here's the difference.
I agree with what you're saying.
And here's what I mean by the operator. Here's what an operator can do, and here's what a technician can do. An operator understands sounds that they have not heard before because they hear a certain sound every day for 8 hours. An operator can understand how the robot moves because 8 hours a day they see the robot move. If it does a movement that they have not seen before, that's different. The thing that the technician does is it knows why that robot deviated. It knows why we're having that noise. That noise is associated with, okay, it's not enough lubrication. Okay, I have a failure, a mechanical failure, and so forth and so forth and so forth. That's the difference between the two. The architect picks, here's the application, here's the robot you need, here's the payload, here's how fast it's going to go, here's the PM cycle, here's the TPM cycle. That's the architect. And that's the issue in our companies today. They want to take all three of those things and put it in one area, and then one guy runs around, and then you don't understand why your system that you paid $10,000, $100,000, or millions of dollars for didn't do what you thought it was going to do.
True. That could be that is so true on so many levels. And you know, the thing is this is where we also get into one of the steps is commissioning these robot sets. However, the problem is we get too many people running by the piss poor commissioning steps where it doesn't make any sense. You know, where, oh look, I'm going to do a yellow, green, and white, yellow, and green buy-off. And we're going to keep doing this archaic way of doing buy-offs over and over and over again. However, if you do your buy-offs where everybody sits there and goes, I approve, and they hit a button on a PC without actually reading anything, without actually validating anything, guess what? You just failed. And for me, doing buy-offs needs to follow like the Scrum process, and robot implementation needs to follow the Scrum process. We need to have Scrum reviews, where you have sprints. Your first sprint can be, let me determine the usage of that robot. So I've now figured out what I'm going to use that robot for. Okay, and I'm going to do a sprint review at the end saying, okay, cool. We've determined through, work balance process that I now know I need a robot for this. Okay, we're there. Your next step needs to be, hey, guess what? Your next sprint is robot determination. What robot am I going to buy that fulfills that quota? And why? And so you kind of work through that process. And then as we get towards the end and the thing is so then it's like, hey, design reviews, that's a sprint. And then safety reviews, that's another sprint. So every step has a sprint. Everything is a week or a little bit longer, 2 weeks, 3 weeks, whatever. But you never let it get away from you. When you start getting into the actual buy-off phase, each one of those buy-offs needs to be a sprint. Okay, cool, I've done all this. At the end of the day, that Friday, I do a sprint review. And I sit down with all of my stakeholders, and I walk through every single step that person was supposed to take. And I validate that every single step is done.
Yeah, I mean, it's a little difficult with processes as opposed to programming. So with programming, like, we have established processes in place, and what I mean difficult is the culture.
Yeah,
it's the planning group or the engineering group. They're doing this stuff 3 years ahead,
right?
So no one is involved. It's hey, it's basically a simulation,
which is a problem,
And okay, now management has made the decision that now we're moving forward. Now we involve the people.
Yeah, which is bad.
So they call it new model or they call it planning or whatever. But that's the issue. So when you start talking Scrum, they've already decided the implementation phase.
Yeah, and the thing is,
because we got to have it in place because we have a contract that requires this. There is no Scrum.
Yeah,
this is happening.
And the thing is that's we go back to the fact that these hey, pat myself on the back freaking engineers, that are out there are the ones causing that problem or aren't validating that issue.
Well, it's management ultimately,
exactly,
because they have to decide have to decide the rules of how we going to interact.
Right,
they have to design the rules.
And the thing is, but it is a management issue. It's a really good management issue, and one I wish I could take care of, but that's not 100% legal. The thing is at the end of the day, it needs to go. It does fall to the engineer, where it's like, hey, let me call these people into a room and sit down and talk to them and see what they think. They might not know what is going on in the future, but you can always brief them on it and say, hey, what do you think? And the thing is, that could be part of a Scrum process. I don't need you the entire freaking time, but I need to have your opinion. I can bring you in on a review and say, hey, guess what? Let's talk about this. Because they're your stakeholder. The person doing the work is a stakeholder. At the end of the day, if you build a system, with a robot and it sucks, at the end of the day, that's on you.
Yeah.
And the thing is, now, what I hate, and this is what I hate the most about this, is where we have a failure in the final step of a robot decision, the commissioning phase. They build these systems and you blame the operator for a bad process that was designed into the thing because you didn't take into account how the operator works the station. And I cannot stand the fact I've seen engineers go out there and blame that operator for what they were doing because somebody didn't build the station right.
So the once again, here's the issue, because I've been on both sides of the fence. I've been on the technician side and I've been on the engineering side. And from what I've seen, most of the time, management has already decided what they want.
Mm-hmm.
Management has already fixed a budget.
Makes sense.
Management says, okay, we've done our assessment. Our assessment says, hey, this is the return. Some companies want 2 to 3 years return on their investment. Some companies want 5 years return. And here's the problem. If I have a reward for making the costs, reducing costs,
right,
whether it means putting in an inferior product, management doesn't care.
Right, exactly.
Finance says, hey, they reduce costs, hey, you get a bonus. So you're awarding people for cutting corner.
Yeah.
That's the issue, because we decided in manufacturing that it's okay to hire somebody that does not know what a robot is, other than, hey, it's a robot. Yeah. Don't know what it does, don't know how it works. I don't expect I don't expect a CEO to know, hey, this robot, it has a servo. What I expect for him to know, that's a 6DOF robot, and that 6DOF robot has this work envelope.
It's capable of this. Yeah.
Our work object is longer than that work envelope. Oh, it's okay. We can make it work.
Yeah.
So this is the issue. The person that's buying the product should know what they want. If you're going to shop for a truck, and that truck has to haul something that's heavy, I don't know, say it's got a it's a hauling car somewhere, 3 or 4 vehicles. Does it make sense to get a truck that can't handle that because it's cheaper? That's the issue. To me, you should not have a person making a decision that does not have the technical capacity to evaluate if this is the right product. Or if you decide, well, I don't need that, I got a process in place, your process should catch it. Either you have a hind catcher that can catch it, or you make sure the person that's swinging at the base going to hit a home run.
Right. You
pick.
And, I think that, I agree with you, this 110% because being an IT guy and also working around engineering and robots and stuff like that, I see the worst of the worst and the best of the best. And, man, we're swinging for the fences every single day. We don't know what we're going to get. However, the one thing that I want to throw in there is commissioning should not be your last step. Like you said, people need to learn this crap. It's, do train the trainers. Do OJT. Do all this stuff. But do it with your management. Teach your management what the heck this stuff is. So, they don't know a KUKA robot because it's orange. Ooh, it's orange. It must be a KUKA. No. It could be something out of China. All right. Even KUKA's out of China, but still. Or it says, ooh, KUKA on this side. Or it's yellow. Ooh, it's Fennec. Doesn't always have to be.
But if you want to do lazy management, that's fine.
Yeah, exactly.
If you want to do lazy management, you should have an independent group of the group that's planning that does...
Validate your process.
Yes. You pick. If you don't, I don't need
process
that.
Validation.
I should have a group that is independent of production, independent of maintenance, independent of planning or whatever, that goes and looks and say, you out of spec.
Exactly. And if you're a small business owner, if you are a small mom and pop shop, the people that we love probably more than anything, because I prefer to buy from mom and pop shops, is the fact that be involved in your decision. If you are the owner of a company and your company has 12 to 14 employees, go run that robot a little bit. Learn it. I'm not saying go sleep with it, but I'm saying learn it. Be involved in its commissioning. Be involved in its build. Understand what it takes for that robot to be used. Understand that robot has limitations. Don't push it to that, for the love of God. It's going to cost you a lot of money. But understand that, hey, it's got limitations. And these are what they are. Be a manager who has at least, well, not besides common sense, but that has the wherewithal to understand why my process is the way it is, why my robot does this, why am I paying for this? There's so many times I've seen management pay for something and go, well, why do we pay for it? They get told about at the end of the moment where it's like, oh, well, we bought this. Well, what does that do? I don't know. We're going to throw it out in 10 minutes anyways. Okay.
Well, I always think back to this. You don't have to be a mechanic to understand that the oil has to be changed in the engine.
Exactly. And it's if your light bulb, if your headlight goes out, guess what? Replace it. If you have an air leak on a robot, fix it. If you're leaking welded water, well, fix the joint. Good Lord.
But after you fix it,
right?
This is where the owner doesn't have to do it.
No.
But the owner has identified the person that has the technical skill.
Exactly.
I don't want to know the why. I want to know the what.
Right.
What are we doing to fix it so that it doesn't happen again? What are we doing to investigate why this happened in the first place? Mm-hmm. I want the what. The why is for the person that's figuring out the problem.
Right.
The what is for the solution you're giving to the person. So don't come to me with a bunch of whys. I want to know what you did or doing to prevent it.
And I agree with you. And I also think that, and maybe some of those what's, the management needs to be involved. Go learn.
If that's the solution.
Why this is happening.
That's called data analysis.
And especially if it's like, hey, we're changing your process. Go look at your process. It's mind-boggling to know that there is management out there who don't understand the process of their company. And I'm not saying that for your small shops. I think your small shops, their owners and their management know their process better than the process owners do.
They probably was doing the process before they became the owner of the company.
Right. You get these guys who are working into major corporations, automotive being the biggest one, that, I worked a week in the line. Dude, you worked in some of the simplest systems in the entire freaking system, but never worked where, hey, guess what? I'm going to go get dirty. If you are a CEO or an engineer, for that matter, and you can walk around a manufacturing facility in a white press shirt freaking with freaking crease sleeves, you're in the wrong job. Because that's telling me that, one, you're afraid to get dirty. 2, I can't trust you. 3, think again about your career path, because what you're doing is not helping anybody. Because that tells me that you're not going to be out there talking to your people because you're afraid to get your white shirt dirty. Or if you're walking around in khakis. You're afraid to get dirty. You're afraid to have those conversations with people. You're unapproachable. If you come walking through there, and I'm going to be very brutally honest, I don't like to really, say too much on this, is if you walk around your shop with a stick up your ass and you're walking around in a white shirt, freaking khaki pants, and freaking wingdings, guess what? No one's going to approach you. No one's going to tell you what the problem is. No one's going to have these freaking conversations with you because you don't look like you belong there.
I can tell you this much. The only thing you're going to find in the book are stories. And stories are fiction. So if you believe everything in a book is the answer, then don't be a library engineer.
Right. Exactly.
Don't be an engineer that takes the library from somebody else and say, hey, what you should do is if you're an architect, an engineer should have a mindset like an architect, like Frank Lloyd Wright. Hey, you can't do that. Why I can't? I did a bunch of studying and I figured out that this shape works.
Mm-hmm. Exactly.
That's still standing. What you want to do as an engineer.
Exactly.
I'm not just going to do the cookie cutter process that the salesman is trying to sell me because this makes this amount of money and I get this amount of commissioning. What you want is hey, what are we getting with this application? Mm-hmm. How will it improve the process? I could care less, and I'm going to say this one more time because people keep making this mistake. I don't care about why. I don't even care about the who. I only care about what and how. What did you do to fix it? Mm-hmm. And how is that going to fix that problem? What and how. That's it.
It's what we call the 5 W's in an age. Who, what, when, where, why, and how. If you
the when, don't care about. The who, I don't care about. And the why, I don't care about. That's the technician.
Yeah, but the thing is, if you come to somebody, any of us, with those 5 answers answered, who, what, when, where, why, and how, you're going to have people out there who are going to be more willing to have a conversation with you.
But I think we disagree a little bit. I think it's a 3x2. You need the 3 to get to the 2.
Right.
So let me say it this way: the 5 W's. Yes, that's typical analysis.
Yeah.
And I'm not telling anybody not to do that. But when I am going to a manager or an owner or somebody that's in a position where they have to make a business decision.
Oh yeah, yeah.
You take the other 3 to derive the other 2.
Yeah, which
you
makes
find
sense.
the what to get to the how. And you have to know
I agree with that.
It ain't just, hey, let's do a fishbone. What? Why? It ain't just man, machine, and method. It's all of those things. And how do all of those things... I'm saying, I'll give you an example. In your daily job and in my daily job, I had people say, well, I couldn't do my job because the data wasn't populating to something.
Right.
That's why. But
yeah, we lost everything else after that.
So how are we going to fix that?
Yeah.
So that we don't have that problem again. And what is your backup plan?
Yeah.
What if this is not available? What if this system is not available? It's offline. Are we just going to stand and cross our arms and wait? Or do we have a
simpler plan behind it?
Is it something else in place we can use?
And the thing is, you know, and I agree with what you're saying. You know, I come at it from, you know, doing, well, military intelligence, which is an oxymoron on its own. But the thing is, you know, for me, you know, you especially for my side being, you know, in a lead specialist role, and, you know, it's I like the 5 W's and an H because I am the one who has to, at the end of the day, take the last 2 and explain that to a manager who may or may not have a clue. But the thing is like you said, and this is where I think that we've covered all your basic processes of deciding what type of robot and what robot you're going to get, right? Mm-hmm. I think there's one small little step that everybody forgets, or at least 90% of the robot implementations forget. What is my backup process? And how do I implement a backup process when I need it the most? When my main process fails, what do I do to back up the process? This step needs to be documented before the buy-off happens.
Yep.
I've seen it so many times where it's like, what's your backup process? Well, you see, we're going to stare at it for 20 minutes. And pray it starts. Well, what if it doesn't start? Well, we're staring at it for 30 minutes and mean bug it for 10 to see if that really gets it going. Really? Because no one's thought about the backup process of what this backup process is. You know, and the thing is coming from IT, I've seen it. Well, my printer doesn't work. Okay. Well, what
is that the only printer?
What's your backup process? Well, I don't know. I was going to stare at it until it started printing something.
But I'm saying, like,
yeah, could you send it to someplace else?
Your printer is it another printer?
Right. And the thing is, but when you get to robot cells, that's where the comedy begins. What's your backup process? Oh, I haven't thought about that yet.
Here's why I like a double cheeseburger over a single cheeseburger. 2 patties are always better than 1.
Oh, yeah. But add bacon to it, it's even better.
Yeah, that's... So here's the thing. By having 2 robots that share the work...
Right.
If one go down, either of the robot can do the whole process.
Right.
That's why you use multiple robots. And you... Over the life of those robots, if I have 50 million cycles, I have just spread 50 million cycles across 2 robots, which means I have 25 million cycles left.
Right.
So, understand what that means.
Yeah.
That's 100 million cycles.
And
right?
The thing is, and this is where it drives me nuts, is that backup process isn't already programmed in. 95% of the time, it's not in there.
You should always have it.
But it's like, what's my backup process? Well, I got to call a programmer and get them to put this in there because this robot doesn't work now. Well, why doesn't the robot work now? Well, it just stopped. It stopped doing things. Well, what did it stop doing? Well, and then you get the look of, I have no clue. But it's, you know, if you don't have that backup process preset where if something goes down, I can go on to an HMI and say backup process to immediately get you back up and running. This is why we have lines who sit for 3 or 4 hours, because people don't realize, oh, hey, guess what? I have a backup process this entire time. Why don't I use it?
Or if you're going to be risky and have a submarine process,
Yeah.
you better ensure that you have some redundancies on that process that's going to kick in. Or you better make sure that you have the world's greatest technician that knows how to get that process back up within a certain amount of time before we're going to be on the bottom of the ocean. Okay?
And if you do, please make him write an ebook.
Yeah, just
To explain to everybody else how to friggin', be able to switch a process real quick without freaking really aggravating nobody.
but what you said was there is something already in place. It's just hey, you have to run this.
Right.
Or hey, you have to enable this.
And make sure people know where it's at.
Yep.
Have it documented. And there's another step that people fail at. Because it's supposed to be in the buy-off phase, is documentation. Make sure it's documented. Make sure every single one of your robots has a robot book. In the Marine Corps, we used to call it the I Love Me book. You take this book, you put all your certificates and stuff like that in it. Have one of those per robot.
Well,
hey, here's the documentation for that robot. Here's the sign-offs, the buy-offs, the process description, where the code is inside the panel, where this code is inside the PLC, where all this stuff is.
Until you make that a something that's a penalty.
Yeah.
Once you make it a penalty that, hey, when I check in the beginning it's not here, check one, penalty. Thank you for that money back.
Yeah.
Hey, this is another check stage for documentation. Penalty. So until you make it to where it's a true deliverable that has to be done in the beginning, I want my documentation first.
Yeah, make it part of buy off.
You better give me basic. No, before I buy the robots,
Yeah.
you're going to provide for me what maintenance I got to do. I want all it up front.
Yeah, makes sense.
I don't want to be at the end writing this. Now, the process that we develop is different.
Right.
The code that was implemented is different. But far as TPM and PM, I want it up front. Yeah. You're going to give me that now, or I'm not purchasing your robot. You get that when you buy a car.
Yeah, and the thing is the your process documentation, code documentation will come in and also your safety documentation will come in your yellow, green, and your white, yellow, and green buy-offs. Because the thing is that book needs to be constantly filled. It needs to have stuff added to it. Yes, a digital system is great. Don't get me wrong. It's great to have a digital backup someplace in the world. But these books need to be on the line. They need to be near the robot, or at least in the general vicinity. Maybe not directly near the robot, but maybe in the maintenance office.
No. You good with that. I'm not saying that you shouldn't have that. But unfortunately, I am an old head. I do like digital.
But I mean
this way.
I think there needs to be two versions. I think there needs to be a digital version and a printed version. Because the thing is if we have a technical issue and your digital version goes down, I have a backup copy that I can turn to that can be in my maintenance archive, can be near my robot, where I can go pull this book, flip the book over and go, okay, cool, that's what that means.
So here's the problem with a physical and a QR or some type of form where I can have it go to a device, a smart device, a tablet, a phone, or whatever. Here's the issue, or a HMI GUI. The issue is you have to turn through every page. You have to go through the index. It is not for a situation where I'm down. That's not what it's meant for. Right. It's more for in the training process. And this is with 20 years of experience, and I love the physical manual. Downtime, when I don't have anything down.
Well, yeah.
For learning. But what I've noticed at the line, anytime we've had those physical things, one, they disappear.
Yeah, that's
Two,
true.
It'll sit right there in the thing, and the people go right by because they forget it's there.
Yep, that's true.
But I do agree, both should still be there.
Yeah, and the thing is even if you do have a a downtime type issue where you're mechanically down, or from my side technologically down, at least Wi-Fi don't work no more or whatnot. But it's being able to call that back, that data back. So it needs to be a physical local copy. If that means putting a tablet at every single robot station with all the documentation with quick links.
Yeah.
And the ability to search through that process, and each one of those tablets only being for that robot, then, that for me is, hey, I'm on site, but I'm also digital and stuff like that, because we spend so much time not being able to find the crap that's wrong with these things. Mm-hmm. And the fact that, hey, guess what? If my operator is waiting to load a part in a robot, they can be reading the robot manual. They can be learning. They can be leveling their skills up to be the next, robot tender or person over that particular cell.
Yeah.
So it's kind of a dual-headed, scenario. And, this is where I would have fun with it because, well, I'm a nerd, is, and one thing I know we didn't really touch on, but it should be kind of well known, is the data organization of a robot. Mm-hmm. Is your downtimes, your warnings coming from a robot should automatically be tied to your documentation. So if I get a, overheating warning coming from a robot or overextension warning from a robot, that should automatically flash on my tablet and go to the page where it's at. That says, hey, guess what? This is how you repair that.
Yep.
And, to make that easier, to make that transition easier. Me being an IT guy, I look at that stuff and I go, woo, that'd be fun. But the likelihood of you getting that documentation and that response from, a lot of companies who aren't thinking about how can I make life simpler, is you're not going to get it.
No, because they expect for, just as the service expect for the guy that's in the submarine that went through a school or whatever school they go through, that they're an expert because they had a mock-up.
Yeah.
And they were awesome on the mock-up, zero stress. Well, we're so many thousand feet under the ocean. If you don't fix this, everybody on the ship dies.
Yep.
So that's the issue. The expectations versus the reality does not match.
Which makes sense.
So, but why would you not have it to where your phone prompts you all the time?
Yeah.
For, hey, I recommend this. Why would you not have your system be responsive? It makes no sense to not have, hey, I got this type of fault. Hey, here's where you should be.
Exactly.
Hey, this is the issue. Hey, it's a motor issue. Hey, this is the issue, because those things are common faults that are in the documentation. Mm-hmm. And if you would spend that money up front and go to a Industry 4.0 system and get away from the archaic 3.0 system, you would find that the smart factory would actually start to help isolate some of the problems. It would actually show you trends and so forth. And then it'll give you one center of truth as opposed to it's a production center of truth, it's a maintenance center of truth, it's a shift center of truth, it's a day center of truth, it's a model center of truth.
Yep. And the thing is there's too many people out there who love the archaic way of doing things.
If you're using Excel, you ought to be ashamed of yourself.
And
for tracking anything, if you're using Excel.
Or Access database for that matter. But, I think that the archaic way of doing things, people have fallen in love with it. People think, oh, we must not change. Look at, and I know we're going well over time. We're going to be well into an hour. But you have more, like Ford Motor Company, for example. Ford Motor Company understands that they need to get out of the archaic times and move forward with how they do things. Chevrolet, GM, they've moved into, doing their own thing. They have an entire GM motorsports complex in Charlotte, North Carolina, where they help design NASCARs, Indy cars, that type of stuff. They have an entire digital campus in Arizona, while Ford is trying to make Detroit better and trying to enrich the lives of the people that they work for. Same thing as like Toyota and some of these other companies, in certain areas of where they're part of, here in the U.S. However, then we get to our fun friends, the German guys. The German factories, on the other hand, believe in the archaic times. they don't want to share the wealth of knowing about the new Industry 4.0, even though they came up with it. Across all of their plants. Because the problem is you have people in leadership in some of these organizations who don't believe in it. They're afraid of change. They're afraid that the issues will expose them to the fact that they may not have a clue of what they're doing, or may expose them to the fact that, they really don't know how to track anything. But, that's here nor there at this point. But, don't be part of the problem, be part of the solution. Go out there and do research in Industry 4.0. Pull Industry 4.0 into this robot process. Because I'm going to tell you, most of the robot controllers can speak MQTT. That MQTT information can be loaded to a database, can be loaded to a visualization software and actually be looked at, and can tell you exactly what's going on, even though people don't want to believe it. It's possible. And it's definitely a way to support the organization, even though, going into the next generation of manufacturing is not going to help anything these days.
Well, imagine this, and then we'll try to wrap it up, guys. Imagine this. Imagine I had a bucket, and in this bucket, I could pick whatever topic I was interested in. And only when I was interested in that topic would I go pick something out of that bucket.
Yep.
And the only time I would be interested in picking something out of that bucket is when something interesting happened for me to go pick it out of that bucket.
Mm-hmm.
Any other time, I do not care. I only care when something interesting happens that prompts me to go pick out of the bucket. And this bucket is available to all the other buckets that are interested in a topic.
Right.
Or something interesting happening involving a topic. Imagine that. And the data is real time. There is no fondling of the data. There is no massaging of the data.
It is what it is.
And I'll leave it at that because maybe some kids listen to this, so I don't want to get too explicit. But the point being, data is not meant to be massaged. Data is meant to be analyzed.
Right, exactly. And, I think that, kind of brings us to the end. And we're definitely going to do, I see the need for this now also, is a episode on how does MQTT support manufacturing. And where we can really get involved in some of those Industry 4.0 and MQTT topics. If y'all haven't had a chance to go take a look at our other episodes where we talked about Industry 4.0 and MQTT, go take a look at those real quick. Because I definitely want to talk about that again, and really get people interested in that process, because the problem is without MQTT, your robots are useless. And we kind of want to build on that, because we want to make sure that people understand why they buy robots, why they use robots. Also, you can tie them to 3D printers, additive manufacturing machines. You can also tie them to your large-scale robot printers that are printing with the pellet extruder heads that we see. Caracol is one of the biggest users of the robot-based 3D printers. We have Italy. They're a great company, by the way. If you ever have a chance to talk to those guys, they're absolutely cool. And same thing with Orbital E, or the company who makes Orbital E of their system. So Orbital Composites is actually the name of the company. They do a lot of stuff with KUKA and their smaller KR3 robots. But the thing is I want to take a minute and say thank you to the 2,527 of you who've actually listened to us, who've taken your time out of your day to listen to us ramble about something. And we can only hope that, at the end of the day, this makes sense. You have fun with it, as much fun as we have with it. And, we want to thank you. Go take a look at the website, vulcanara.com. We kind of changed some stuff around a little bit. Go take a look at Printed Heritage, the blog. Also, you'll see some stuff come out merch-wise for, through Vulcanara 3D. There you'll kind of see the new, we're designing a new logo, so you'll see that new logo come to life here in a little bit with a little bit more behind it. We do have, for all you gearheads out there, we do have a couple more announcements coming out towards the end of the year. So we hope that y'all enjoy that and stuff like that. So we'll probably be doing some more automotive content. Probably around the November timeframe. So. But, with that, I say thank you and turn you over to Ed.
Yeah, appreciate it, guys. Appreciate you listening. Glad to be back. It's nice to spend time with you guys and share some knowledge and talk about topics that we're interested in, and hopefully you guys are too. So just keep listening. We'll keep bringing content. In the future, we'll try to do some other things. We're still trying to work out the logistics for doing something live, or maybe we can do some meet and greet somewhere, but we'll appreciate all support and thank you.
All right, y'all. Y'all have a good one, and we'll talk to you later.
All right, bye.
Bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanara Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.